low-pressure system fills the rod end of the hydraulic cylinders during the forming stroke. The filter and cooling system removes contaminants from the hydraulic fluid and keeps it at its proper operating temperature. Two Temposonic linear transducers are mounted to and move with the cylinders to monitor the position of the cushion. The Temposonics consist of a metal rod with a sensor that is mounted to the press and doesn't move, and a bracket that holds a donut-shaped magnet. The magnet creates a magnetic field around the rod, and as the cylinders extend and retract, the sensor detects changes in the magnetic field and sends this information to the controller, which converts it into position information. The cushion is in its highest position when the press cycle starts. This position is referred to as the return position. A blank is placed in the draw die as the slide begins its downstroke. As the slide lowers, the cushion controller watches the press encoder. When the press encoder reaches a specified press angle, the controller knows that the dies are about to make contact. So it begins the pre-acceleration phase by shifting the three-way servo valves to allow high-pressure fluid from the accumulator to go into the rod end of the cylinders, and at the same time, opening or closing the servo-operated relief valve to maintain pressure in the cap end of the cylinders at 850 psi. This causes the pressure pad to accelerate to 50% of the slide speed just prior to contact. This creates a soft hit between the upper and lower die binder rings. Without pre-acceleration, the binder rings will hit hard. Softer hits reduce wear on the dies, compress components, and reduce press vibration. Once the two binder rings make contact, the three-way servo valves shift to their closed position and stop the flow of hydraulic fluid to the cylinders. Meanwhile, the slide continues down and compresses the hydraulic fluid in the cap end of the cylinders. As the pistons are driven down, low-pressure hydraulic fluid from the air-over-oil tank flows through the check valves to make up hydraulic fluid in the rod end of the cylinders. If a check valve fails for any reason, air could enter the cylinders. If air gets into the cylinders, it can cause the cushion to behave erratically without displaying any faults. After the pre-acceleration phase, the slide continues downward and resistance tonnage builds in the cylinders. The servo-operated relief valves control the resistance tonnage by releasing more or less hydraulic fluid from the cylinders. The more fluid released, the lower the tonnage. The less fluid released, the greater the tonnage. The servo-operated relief valve can be set to maintain a constant tonnage throughout the forming stroke, or can be set to vary the tonnage. The Versant cushion can accept up to 5 tonnage settings depending on the length of the forming stroke. The tonnage produced during the forming stroke is referred to as the pressure profile. The ability to change the pressure profile throughout the forming stroke allows an operator to precisely control metal flow in key areas that may be prone to splits or wrinkles. By controlling how fast the servo-operated relief valves open, you can control how fast the resistance tonnage is attained at the beginning of the forming stroke. If the valves open too quickly, the tonnage may be too low, which may cause wrinkles. If the valves don't open fast enough, a pressure spike can occur. This can unsplit. If you need to adjust the speed at which the valves open, you should go to Oil Gear Screen 61 and enter adjustments here. The panel is fully formed by the time the slide reaches the end of its forming stroke, which is usually around 179 degrees. Somewhere between 180 and 183 degrees, the servo-operated relief valve fully opens and releases all of the oil in the cap end of the cylinder. This is called the decompression angle.